Alright, we're going to calculate the centripetal acceleration of the Earth in its orbit around the Sun and the net force exerted on the Earth. We also want to know what exerts this force on Earth. We're going to assume that the Earth's orbit is a circle of radius 1.5 times 10 to the 11th. So we're going to write down what we know. We know the radius is 1.5 times 10 to the 11th meters. And we also know that it takes the Earth 365 days to go around the Sun. So we have T equals 365 days and 24 hours in a day, 60 minutes in an hour, and 60 seconds in 1 minute. So what we can find is that that is equal to 3.15 times 10 to the 7th seconds. Then we're going to use AR equals v squared over r to find the acceleration, which we are going to have to use the function for the velocity that's related to the period. So we have 2 pi r over t squared divided by r. If we square that out, we get 4 pi squared r squared over t squared r, and r is going to cancel, and we get 4 pi squared r over t squared. We then are just going to plug in. We get 4 pi squared r is 1.5 times 10 to the 11th, and we have the t, which is 3.15 times 10 to the 7th, and that's going to be squared. And that equals, we have 5.97 times 10 to the negative third meters per second squared. Then we also know that the net force is equal to m times AR, where the mass of the Earth is going to be 5.96 times 10 to the 24th. So we have 5.96 times 10 to the 24th times 5.97 times 10 to the negative third. And we're going to find that that is equal to 3.56 times 10 to the 22nd newtons. And what force this is it is the force of